welcome to Tech Talk. My name is Clayton Forbes. I'm one of the operations managers here at National Technical Systems, aka NTS. Today we're going to be covering MIL-STD-810H, sections of methods 501 for high temp, method 502 for low temp, and method 503 for thermal shock. So MIL-STD-810H came out in January of 2019. It's the newest document in the family. But in order to get into the document, got to do a little background. So MIL-STD-810G is a guideline. And in order to apply it, you really need to go to Part 1 of MIL-STD-810H, which gives you an idea of how to get your life cycle. And not everything in 810H applies to every product. So once you get your life cycle down, you can figure out what method actually applies to your product. Once you figure out all of that, you can go to Part 3 of MIL-STD-810H, which gives you the climatic conditions, because pretty much all the curves are pretty much generic inside 810H. So with a little bit of background between Part 1 and Part 3, you can put that data together and figure out what tests you really need to run in 810H. So like I mentioned, today we're going to cover method 501, which is high temp, 502, which is low temp, and 503, which is thermal shock. So to get started, the first thing we need to know is obviously the temperature you're going to, the size of your unit, the power requirements, if it's 400, 440, 28 volts. That way we can figure out the thermal load in the chamber, get you into the right chamber. All right. Along with that, we need cables. You need a length of cables, usually 6 to 10 feet is a good length. All the chambers here at MTS have 3 or 4 inch ports to get your cables out, so we can do the operability part of the test. And we'll also need some access to your unit. 501 and 502 both have thermal stabilization portion, so we're going to get some thermocouples inside your unit to prove thermal stabilization. If your unit's kind of sealed, we can't get thermocouples in there, it's still not a loss. We've done some thermal analysis. We can use that data. We can map an old unit and hone in on what the test temperature we need to do. All right, so now we got your unit. It's going to go inside the chamber. For storage, which is procedure 1 in method 501 for high temp, it's going to be in its storage mode. It could be in a crate, however it's shipped. It could be sitting on a tarmac. P3 is tactical, standby to operation. So depending on the configuration we need to do, we'll put it in your chamber in that configuration. Obviously do a visual exam of the unit, do an operability check before we run the test, get it all down, get it all together, and then we'll start the test. So with the thermal stabilization going. So we'll ramp the chamber at a very slow rate, less than 3 C per minute. Get it up to your temperature where your requirement would be. Monitor for thermal stabilization for P1 and or P2. Once it's thermally stabilized, now we have a choice that we've already determined. That choice would be either do the steady state or the cyclic. If you're not sure which one you need to do, worst case scenario is you do the cyclic, which is 7 days, 7 24-hour cycles. So you ramp it up, thermally stabilize it, add on the dwell time, ramp back down at less than 3 C per minute, restabilize the unit at ambient temperature, and you repeat this 7 times to go through the test for P1. Once that's all been completed, we'll go inside the chamber, visually check the unit, make sure it looks good, fire up the unit and make sure it still operates, and continue on from there. Where we run this in the test sequence, because there's 28 methods in MIL-STD-810, usually we'll run this early in the method, early in the testing sequence. It's considered a benign test or a low risk test, get some pass-fail under your belt, but determining your life cycle could fall somewhere else. So, I'll work with NTS prior to that to make sure we run the test in the sequence you need it. More than likely we'll run it early in the test profile. All right, so we've gotten through high temp storage. Now we're going to move on to high temp operability. Again, it's going to be a different chamber from your research from part 1 and part 3. It's basically the same test, so to speak. With your unit at ambient temperature, we're going to raise the temperature up to whatever that temperature may be. This could be a 3-cycle test, or it could be a steady state test. Once it thermally stabilizes, we can dwell for 2 hours or perform 3 24-hour cycles on the unit. The whole time monitoring for operability. Operability tests that should happen at the temperature extreme, i.e. after you've thermally stabilized while you're doing the 2-hour dwell. Just before the 2-hour dwell ends, make sure it operates, and then we'll ramp it back down. This test is a little bit more of a risk than the storage test. Most chipsets commercially available off the carts off the shelf can't handle some of the extreme temperatures that MIL-STD-810H goes to, or any of the MIL-STD-810s used to go to. So we do see some failures here once in a while, and also if you keep running into this problem where you keep failing and failing, you could run into an issue with some thermal aging. Where NTS ran into this problem once, we actually were running PCB cards. We're doing ESS screening. They gave us a chassis at the beginning of the test. We plug in these cards, go off and do some screening. We ran this test for 6, 7, 8 months without a problem, and all of a sudden we started getting failures. And we actually talked it down to the chassis itself. It had some controllers in there, and we actually ended up getting the chassis to the end of life. So keep that in mind if you start seeing new failures after you've run this test a few times. Make sure you haven't run it too many times that your product's reaching end of life from its thermal aging properties. All right, so that's P1 and P2. P3 is tactical standby to operability. Basically, if your unit's sitting out on a tarmac or sitting out in the desert, wherever it may be, it's sitting there, all of a sudden it has to go to operability. So we're going to raise the unit up to its non-operating temperature. We're going to let it thermally stabilize, and once it's thermally stabilized, we're going to drop the temperature at around 2 C per minute, no slower than 2 C per minute. Once the air temperature reaches your max operability temperature, we're going to turn on your unit. So that's going for tactical. So obviously your unit, depending on its mass, the temperature of your unit could be pretty far behind the chamber, or it could be right on it again. It depends on the mass. And then once we get it to operability, make sure it works, shut it off, ramp down the room temperature, and then we'll go off and do the operability and the visuals and everything else we can do. So that's pretty much method 501. Method 502, pretty similar, opposite direction. The thing with, even with method 501 is, if you need access to the chamber, with method 501 you might need access as well if you don't have remote operability. We use liquid nitrogen in most of our chambers, so we're going to have a confined environment, low oxygen. So prior to coming to NTS, just make sure we know if you need access to the chamber to put it in a man-rated chamber. We got reach-in chambers as well, so where the LN2 bump might not affect you. Even at high temperature, if your unit's putting on enough wattage, temperature chambers will end up using LN2 to keep the chamber cool, because you're dumping so much wattage into the chamber. All right, so we digress. So back to method 502, low temp. So basically the same thing. We have a storage test. If pot 1 told you you're gonna, I'm sure you're probably gonna find that you're gonna need to do this. And pot 3, the temperature. Put your unit in its normal operating state, shipping state, standby and manipulation state, whatever your life cycle the turn. We'll bring the unit down temperature, let it thermally stabilize. We'll sit there for an additional 2 hours and bring it back to room temperature, visual exam, operability for P1. Most clients will run P1 followed directly by P2, and that's basically from low temp storage, you bring it up to low temp operating temperature, whatever that temperature may be. Then we let it thermally stabilize again, and we power up your unit, we let it thermally stabilize again, and once you're thermally stabilized, perform the operability test near the end of the 2 hours. In between, you can add in P3, when you're going between low temp storage to low temp operating. You can go in there, do your manipulation, If it's a reach-in chamber, you just need to use some heavy gloves. If you're actually going inside the chamber, you're supposed to wear outer gear and get the unit from its storage condition to its operability condition. So that's basically P1, P2, and P3 all combined together in method 502. All right, the next method is method 503, which is thermal shock. Thermal shock happens when you don't even think it happens. Just think of carrying your cell phone inside a nice air-conditioned building, walk outside in the hot sun, could be in Phoenix, Arizona, or vice versa, a nice warm building in Boston, and you walk outside into a nice cold atmosphere. So thermal shocks happen when you don't even think about it, it's happening. So in this method, we actually have 5 procedures. There's P1, P1A, P1B, P1C, P1D. Basically all the same thing. It's a shock that's going to happen in a minute or less. We're going to get your unit stabilized. We can either do it in a thermal shock chamber where it moves it from, so both chambers are going to be at the set temperature, whatever, T1 or T2. So we'll call them T1 and T2, just like 810H does. So we'll set the unit at T1, ramp it down, get it at T1. We don't want to thermal shock it yet. The other chamber is going to be set at T2, and in less than 1 minute, we're going to take the unit from one temperature to the other temperature. We can do it, like I mentioned, in a vertical thermal shock chamber, a horizontal shock chamber, or even open up one chamber, pull it out, and move it to another chamber. So that's a shock in halfway shock. We can do a full shock, which is method 1B, which basically is we take the unit, ramp it down to T1, move it in 1 minute to T2, move it back to T1 in 1 minute, and completely shocked. And then the most common one is the multi-shock, where we'll do 3 shocks. And basically it's room temperature, bring it down to the low temperature, T1, bring it up to the high temperature, T2, and do it multiple times, and then at the completion of the test. Usually during this test the unit is non-operational, but we can do it operational as well. Thank you for joining Tech Talk.